Let's see one question before going ahead. Battery B, R, 2R, 2R, and C. This is the current I. The switch is closed at T0. Find the current at T0 and infinity. At T0 and T infinity. Let's get this. Steady state circuits people. Last time we did this thing. Try everyone. Others do keep your cams on. Clear? Let's see. How to do T0? What happens to the circuit? Everyone, what happens at T0? How does a capacitor behave?
Like a wire.
At T0, it becomes a wire. So the circuit would look like this. Two R, and V. So what is R equivalent? 2R and R are in parallel. 2R by 3. 2R by 3 plus R. R equivalent is 5R by 3. And this is the current I here. So I will be 3V by 5R. At T infinity, capacitor will become like an open circuit. Standard models, easy one this is. So this current I will be V by 3R. Please check. Easy. There are two 2R resistors, but upper 2R, okay, ये भी 2R है ना, my mistake. 2R था, yeah. So 2R will be R, RR will be 2R actually, sorry. Yeah, my mistake. Right, Asim, you're right. All got this? Easy?
सर ऊपर वाले केस में अगर 2R और कैपेसिटर का पोजीशन स्विच होता तो स्विच ऑफ लगाना पड़ता।
कहाँ पे 2R और
कैपेसिटर का अगर पोजीशन स्विच होता, अगर मतलब रेजिस्टर पहले होता फिर कैपेसिटर होता तो
फर्क नहीं पड़ेगा, कुछ फर्क नहीं पड़ेगा। करंट तो नहीं जाएगा ना रे उस ब्रांच में, वो ब्रांच में तो करंट जाएगा नहीं, तो कुछ डिफरेंस नहीं पड़ेगा। ठीक है, all clear with this thing? So last time we saw circuits, you know, 1R and 1C, but advanced may you get questions of this sort also. Please take any doubts on this. What happens if we want to find it as a function of time t for another circuit? So let's say we have resistor and a capacitor like this, V, R, 2R, R, and C. The switch is open, it's closed at t is equal to 0. Find charge on the capacitor at time t. Not steady state, find charge on capacitor at time t. How will you do this? Try. So this I'll teach you in two ways. First, I'll teach you with integration, and next I'll teach you a shortcut, faster way to get the answers for these kind of questions. But first, let's give it a try. Because you should know a general method. A shortcut has its own limitations. How do we try this? How do you approach this? Let me show you. This is slightly tough. So these are non-steady state circuits actually. And remember, these circuits are quite useful because the same thing will again come in LR circuits later on in EMI chapter. So this is V, R, 2R, R, and C. This is how we do Kirchhoff's law. Let the current be I. So this current is I. This is small I. This is I minus I. So, and let this charge be Q, and the current is going back here. So tell me one thing, if I write dq by dt, what is this? Which current is dq by dt?
Or it is small I.
Small I or capital I?
Small I.
Small I, na? Because Q is the charge on the capacitor, so rate of change of charge should be current in the capacitor, isn't it? If Q is a charge on the capacitor plate, so then I should be the Q is a charge on the capacitor, so dq by dt should be current in the capacitor. So I is the current in the capacitor. So apply Kirchhoff's law. I'll write in this loop and I will write in this loop. I'll start from this point here. For the left loop, the equation would be V minus I capital R minus I small 2r is equal to 0. That is a loop. So from here we get V minus 3IR plus 2 small ir is equal to 0. The right loop, I can start from here. I'll go this way. Minus IR, then you're going from positive to negative plate minus Q by C plus I minus I into 2R is equal to 0. Please check your equations. This would be minus 3IR minus Q by C plus 2I capital R is equal to 0. I capital R is V plus 2IR by 3. First, please check the equations. Look at the signs. It is important. 1 plus and 1 minus and will mess up the whole thing.
So we can take that whole circle also.
Whole circle भी ले सकते हो. Then take this IR from here and substitute in this. So you know what am I trying to do? I'm trying to eliminate capital I. Why? Because I want small I in terms of Q. So this will be minus 3IR minus Q by C plus 2 by 3 V plus 2IR is equal to 0. So bring all i's together. This would be 4 by 3 minus 3 minus Q by C, 2V by 3 minus 3 minus 4 by 3, 9 minus 5 IR by 3. I'll show the integration in the next class, next chapter, next page. Have a look at this equation once. Main thing, if you got the equations, half the job is done. It is just max from here. Clear? Vrinda, Labdi, clear with this? Shaurya, Devanshu, Anamay?
Yes, sir.
Kavish, Trisha, Danya, equations are clear? Gauri, got this? Now, how to solve this thing? So minus Q by C plus 2V by 3 minus 5 IR by 3. So minus Q by C plus 2 by 3 is equal to 5r by 3 into I. So bring that I is nothing but dq by dt. So this will become dq by 2v by 3 minus q by c is equal to dt 3 dt by 5r. Integral on both sides, 0 to q and 0 to t. That integration will become minus c ln 2v by 3 minus q by c limits 0 to q is equal to 3t by 5r. So this would be minus ln 2v by 3 minus q by c. Put 0, you'll get minus ln 2v by 3. Send that minus and c that side. It'll become minus 3t by 5rc. Divide them, you end up with 1 minus q 2cv by 3 is equal to e to the power of minus 3t by 5rc. I'm skipping a lot of steps. So q will be 2cv by 3 into 1 minus e power minus 3t by 5rc. This is the charge as function of time t. And what's the time constant here? Time constant is 5rc by 3. Because the time constant is e power minus t by tau, na? So tau ka place mein you have 5rc by 3. So q is equal to q into 1 power e minus t by tau. This is how you actually do the problem with pure integration. It is actually max. So once you write these two equations, right, simply become a max car question. Please look at the steps. And this method is important because if they ask you something, I'm going to teach you a shorter way, but that shorter way has one limitation. So if they give you something like this is the only way to do. Clear with this? Do have a look at this. Clear. Now let me teach you a shorter way. Sometimes in the question, what they'll ask you, right? They'll just ask you, find the time constant. They don't want everything, but just want time constant. So how do you find the time constant of a circuit? Step 1. Replace the batteries with a wire. You can have 10 batteries, there is no problem. Step 2. Find R equivalent. Find equivalent resistance across the capacitor terminals. Step 3. Time constant tau. Yeah, this also is important in units and dimensions. Find the dimensions of R into C. Time constant is given by R equivalent into C. Now, why is this working? I'll just tell you a basic idea. If you go back to RC charging and discharging circuit, what is the time constant in this charging circuit? Mein? Anyone? What is the time constant in this? RC, right? When I take the discharging circuit, what is the time constant in this? RC. That means if you replace the battery with a wire, charging circuit becomes discharging circuit. Getting it? So let me take an example, see how to get this time constant. Example, the question just now we did. Capacitance R, 2R, R. This it's a direct mains level question, find time constant. So step 1, replace the battery with a wire. The wire, resistance R. So there you are finding the potential across these two terminals A and B. R, 2R, and R. If you look at clearly here, this resistance and this resistance are in parallel, isn't it? I can just rearrange it like this. So this is R, this is 2R, and this is R. So what is R equivalent? 2R and R are in parallel, 2R by 3 plus R, 5R by 3. What is time constant? 5 RC by 3. What is the time constant? 5 RC by 3. Did you see how fast we got it without any integration, anything? Exam, if they ask you to find time constant without integrating all this stuff, you can just find the time constant by replacing the battery with a wire and finishing it off. Have a look at this. This is how you can find time constant for a circuit. Please check the steps what you did.
So R and 2R will be in parallel. Okay.
R and 2R will be in parallel, yeah. And that and R will be in series, no?
Yes.
Yeah. Clear, everyone? Please check. Next one. Same thing. You tell me the answer for this guy. Find time constant for this circuit.
Sir, can you show once last page? No, sir. Yes, sir. Okay. Sir.
Clear?
Yes, sir.
Get this time constant, everyone. So I can give you any random circuit and ask for time constant. You just have to follow the steps. Step 1, replace the battery with wires. 100 batteries, that doesn't matter, make them wires. Find R equivalent, remove the capacitor, find the resistance across it and multiply R into C. A problem, only issue is valid only if there is one capacitor. There should be only one capacitor. You can have 100 batteries and 100 resistors. There's no problem. That is the only limitation. Get this?
Sir, 3R by 2.
वो टाइम कांस्टेंट नहीं है, टाइम कांस्टेंट पूछा मैंने.
अच्छा, एक मिनट. Into C.
Yeah. सी भूल गया तूने.
हाँ, वो मैं कंफ्यूज हो गया. C क्यों नहीं?
करो करो others, try I'll give you a minute. It's raining pretty badly. Non-stop था morning से. Luckily for us, online classes rains don't affect. And how is it Delhi? How is it in Delhi, Vrenda? Hot, cold, raining?
It was raining for the past few weeks, but now it's not
I
raining.
heard it got flooded, na?
Yes, it did. I had online school for a day.
Chalo. IIT में ना first year, my hostel used to get flooded every year. Mandakini hostel. We used to have a boat inside the hostel. Our hostel is the only hostel in the entire campus to have a boat inside. So during every rainy season, right, it used to get filled up. Itna kharab tha. I still remember my first year. The room mein na, morning I was sleeping. I woke up, I kept my hand down and water touch ho raha tha. I thought it was a dream. When I got up the bed, there was water everywhere in the room. It was coming till, you can say, it is like around half feet of water in the room. मतलब बाहर hostel तो पूरा भर गया था. So we started playing for some time. Your juniors na itna pata nahi tha. Then seniors started shouting, "Idiot, stop playing! Get out of the water." We asked what happened. Leeches aate hai. There are leeches in the water. That we don't know na. We are playing. We all pressures to kuch idea nahi hai. We are jumping around and playing in the water. So then they shifted us to the third floor temporarily for 2 days. When I came back to the room was a mess. So luckily that time we didn't have so many smartphones and devices, so kuch problem hi nahi tha. Max I had a Nokia mobile. So we had a boat. There was a big issue actually because IIT Madras that year spent almost 15 crores in order to make sure there is no water logging in the Madras IIT. Then there was a big inquiry like, why did the water come after spending so much money? Then these people, when they inquired, they found out there is a water outlet which goes from IIT to the outside. There was a big construction there. Since the water is coming out, the builder got frustrated every day. He kept a big rock blocking the water pipeline. He sealed that pipeline and he constructed the building. His plan was to remove that rock after the building construction got over, but he forgot. It was a mess. So these people filed a case on the builder. Oh, kuch bahut issue hua tha. But we are happy, like we got 2 days holidays. So yeah. How to do this thing? So make the battery into wires, wire, resistor, terminal. This battery also becomes wire, and there, R, and R. So you're connecting the battery between these two terminals. So if you see R and R, these two are in parallel and both are in series. R equivalent will be 3R by 2. Time constant will be 3RC by 2. Please check. Easy? Clear. Let's see. Now, what is the general technique I'm talking about? So whenever you give a circuit like this, it is pretty complex to find charge as function of time t. This is a general solution. One thing, if you observe all this thing, right, there will be exponential functions. So the charge on a capacitor Q.
Sir, but if there are multiple capacitor, how we will know कि मतलब कौन से वाले पे
नहीं कर सकते, वही बोल रहा हूँ ना, you have to integrate. करेंगे equation. So charge on a capacitor will be, general solution will be A into B into A plus B into e power minus t by tau. This is a general solution. So any equation with one capacitor can be written in the form of A and B are constants here. A plus B into e power minus tau. Tau is called time constant. So what are the steps involved? Step 1. Now think about it. Somehow, if you can find A ka value, B ka value, and tau ka value, your job is done. Find tau. Step 2. Find charge at t0. Step 3. Find charge at t infinity. So 3 equations, 3 variables. From there, we can solve and get it. Let me show you an example. Have a look at this. This is a general way of solving without you can completely skip integrations. Clear with this page? Any doubts on this? Show you an example. See. The same question which we did with integration, I'll do that without integrations. V, R, 2R, R, and C. Okay. Step 1. Find the time constant. What is the time constant of this? Make this thing into a wire. Abhi kiya tha humne ye. So I'll just put it down again for you. So R, 2R, R. So time constant will be R equivalent, which is 5R by 3C. Step 2. What is the initial charge? Q initial is 0. So in the formula, we can write Q is equal to A plus B e power minus T by tau. Q is 0, A plus B. This is your equation 1. Step 3, charge at infinity. How do you find charge at infinity? Do you remember steady state circuits?
वो hollow कर देना था मतलब charging.
Battery वो remove करके करना पड़ेगा ना. Last class we did this thing. See, wasn't this the question? Find the charge at infinity. Similar question tha. So how do we do that? At T infinity, this is how the circuit looks. This is V, R, 2R, R and C. All the current will flow in this branch. In this branch, current I will be 0 and this charge will be Q. So we can find I is equal to V by 3R. Current won't flow in the capacitor branch. Then you can apply Kirchhoff's loop law in this loop. We get minus I into R minus Q by C plus capital I into R is 0. Small I is anyway 0. So this term is 0 minus Q by C. I is V by 3R. So this will be V by, sorry, 2R.
I into 2.
This will be 2V by 3R. 2V by 3. 0. So we get Q is equal to 2CV by 3. This is the charge at infinity in steady state. This itself is a bits level question in the exam. Find the charge on the capacitor at infinity. Please ask me if you're confused here. So Q final is 2CV by 3. So the formula is A plus B into e power minus T by tau. Q final matlab T is infinity. So 2CV by 3 is equal to A plus B into e power minus infinity. That is 0. So A is 2CV by 3. A plus B is 0. So B is minus 2CV by 3. हो गया ना? Put it in the formula. Q is equal to A plus B, 2CV by 3, 1 minus e power minus T by tau minus 3T by 5RC. Isn't this the same answer we got without integration, with integration? 2CV by 3 into 1 minus e power minus T by 5RC. Check. See, exact same answer though. The advantage of this method, you can completely skip integration. But the disadvantage, it is valid only when there's one capacitor. Please check the steps. I'll give you one more like this. So pretty good one. You can skip integrations and you can solve. These are advanced level problems.
Sir, at t equal to infinity उसमें current ही नहीं है तो charge कैसा है मतलब it was
अरे
before t infinity.
God, what is current? Rate of flow of charge.
हाँ, okay.
Charge flow नहीं कर रहे, but it got full already. Full हो गया इसलिए charge flow नहीं कर रहे हैं ना.
Okay.
ऐसा सोचो ना. Initially when the charge was flowing, the capacitor becoming full. When it has become completely full, it is not letting any new charge come. So rate of flow is 0. But
Okay.
there is already some charge sitting inside.
Okay.
Shaurya, ऐसा है ना. The charge on the capacitor is repelling the new charge which is coming. तो इसीलिए नहीं आ रहे charge.
Okay. Okay. Yes, sir.
वो steady state का condition था ना. Everyone, please have a look at this step by step. It's a pretty good one. I'll give you one more like this. And most of you are not sending the reports today. People, get back to work. Please start sending reports. Do work sincerely. Start sending your work, whatever it is. Keep a track of it. I'm telling you again, don't leave it right now. You will be able to handle the work. This is what I keep telling you every time. You have to do 100, but you can do only 60. Chalega, 60 karo. Keep doing. You don't know what can happen to the last day. This year, bits ka cutoffs have gone down. Huh? Even 275 bits, Goa में CS मिल रहा है 275 to 879 में, out of 390. So that's what I'm saying. You never know what can happen to the last day. Don't give up. Put a fight. Because everyone who is struggling ना, सब लोग वही सोच रहे हैं. अरे इतना hard है, I will give up. Good ना, let them give up ना. They'll make a way for you. Always think that way. When it is hard, it is good because others are going to give up and they'll make a way for you to go. Check. All I'm asking is pretty simple. After every class, take the notes, make sure to do them again on your own. That is step 1. Step 2, ho gaya, take out your classes ka material or take out my booklet and start solving these questions. Step 3, every weekend I'm conducting an exam, make sure to write it properly and sincerely give it a try and resolve the paper. You have time, start doing previous year questions. Bus, I think this much you can do. I'm sure things will be very good for you when December comes. Clear? Let's see a question like this. Can I turn the page? Any doubts on this? Anamai, clear now? Danya, Trisha? Clear? Kavish? Rena, tired? Nowadays, you're too tired sometimes. What's happening? Netflix? Too much studying? Batman? No. What happened? You're feeling bad because you can't go to Oppenheimer. It is 18+ movie. Isliye. Rishito is going for Barbie. Huh, Rishi?
Yes,
नहीं?
definitely.
everyone's going for Barbie.
चिरायु भी जा रहे हैं क्या बारबी के लिए?
मैं दोनों जा रहा हूँ सर, of course.
They don't check ID cards क्या Oppenheimer के लिए when you go inside?
हाँ वो भी अरे वो कर लेंगे कुछ तो हो जाए. It's not something मतलब bad ना, थोड़ा बहुत violence ही है ना. लिखा हुआ है.
चलो ठीक है. Let's see a problem. The people are saying that only. Sir, Oppenheimer they won't let us go. We'll go to Barbie करके. ठीक है यार. At least the movie. I feel the Barbie movie might be more vulgar than Oppenheimer. Anyways, 29, 30. Let's see. This slightly complex one, but let's see how to do this. So R 2V V capacitor. But let's say on this capacitor, you already have some charge here. This is the positive plate plus 2 CV. This is minus 2 CV. Find the charge on the capacitor at time t. So let's say this is the switch here. This is a proper advanced level question. Find charge on the capacitor. Find the charge on the red plate after time t. Let's get this.
सर वो इंटीग्रेशन का लिमिट्स चेंज हो जाएगा.
नहीं इंटीग्रेशन नहीं करना है ना. यूज द जनरल मेथड ना. अभी तो वही सिखाया. You can solve with the general method. Q is equal to a plus b per minus b t by tau. तो पहले टाइम कांस्टेंट निकालो. Just give me a minute, right? Yeah, sorry, nothing. It's raining too badly now. Parents are calling, sir. Tomorrow there's a class. No. So we are canceling the class. Not our class. No, actually today what happened? Our staff also who left at evening 3:30, they reached home at 8 o'clock. Train se itna late ho gaya tha. Kalyan and Ulhasnagar, that side. So it is pretty bad. Sure. So our staff is also getting stuff pointless. इतना क्यों तकलीफ लेने? Okay, let's see how to do this thing. Step 1. Find time constant. How do you find the time constant? Make it a wire. Resistor, we have done this just now. So resistor. So R equivalent will be R by 2, 3R by 2. So time constant will be 3RC by 2. Step 2.
Sir, A is 2 CV.
Q is equal to A is to CV. वो क्या होता है? A plus B e power minus T by tau. Now be careful here. At T0, what is the charge? 0 नहीं है. T0 charges
2 CV.
2 CV.
And this will be A plus B. This is your equation 1. The second one, this is more complex actually. At T infinity, इतना complex नहीं है. The circuit will look like this. I'll go back to the previous one. V, 2V, R, and R. All the current will flow in the outer branch I, and in this branch the current will be 0. And let this charge be plus Q, final charge. So from here we'll get I is equal to V by 2R. In this loop here, I is 2R. And write a loop in this loop mein equation likhna. You get V minus IR minus small I into R. You're going from negative to positive plate plus Q by C minus 2V. You came back to the same thing. Please check that equation, the left loop. Please check this thing. Then this would be small I is 0. So V, IR will be V by 2, 0, Q by C minus 2V is equal to 0. Q by C is equal to 3V by 2. Q is equal to 3CV by 2. Check. The final charge on the capacitor plate will be 3CV by 2. Any doubts on this? Please ask me. These are, I'm telling you, see, this looks like a big question, but ek question, ek part. Find the charge at infinity is a proper mains level question. Find the time constant is a mains level question or a bits level question. If you combine everything, it becomes suddenly an advanced question. Please check this step. Anyone not clear with this? Amu, clear with this? Labdi, clear, na? Got this? Asni? Sure? Abhiksha? Vrinda? Clear? Arushi, where are you? Trisha, Arushi didn't come today. Okay. Now, once we got this thing, so step 3. So Q is A plus B e power minus T by tau. At T infinity, Q is equal to the Q final, which is 3CV by 2. Which is A plus B e power minus infinity. So that is A. So if A is 3CV by 2, I don't know A plus B is this. So A is 3CV by 2 and B will be CV by 2. Okay, na? This is your final answer. So Q is equal to A plus 3CV by 2 plus CV by 2 e to the power of minus T by tau. So minus 2T by 3RC. This is the charge as function of time t without any integration. Please check the steps. Any doubts on this? Please ask. Easy? Next one. So these are one type of questions, right? There is another type of questions, graphical based on charging circuits. So the question, something like this was asked in the exam. They said there are two RC circuits, C1, R1, battery is V. C2, R2, battery is V. The question was, when you plot I versus T graph, one graph was like this. This is the R1 C1 wala graph. Another graph was like this. R2 C2. Initially, the value starts from the same point. So the question is, compare R1, R2, compare C1, C2, which is bigger, which is greater. So we have two RC charging circuits. This is a graph of RC charging circuits. So same battery, R1, C1, R2, C2. So when you draw the graph for both of them, current versus time, it is found out this is how the graph looks. So the question is, who has more resistance and who has more capacitance? Try. R1, R2 are same, right, Kavish, and capacitance. Think. At T0, what is the current? At T0, what happens to the capacitor?
मतलब we can consider to be not there.
लगा वायर ना?
Yeah, wow.
So at T0, circuit ऐसा हो जाएगा. This becomes R1 V. This becomes R2 V. That means this current I1 is V by R1 and this current I is V by R2. And you're saying here I1 is equal to I2 is equal to I0. That means R1 is equal to R2. Isn't it? Initially current is same. What about C? Can you tell me who has a bigger time constant? Again, what is time constant? Time constant is the time when the value of the current becomes 63% lesser. So 0.37 I0. So you tell me, who is decreasing faster? Who is reaching 0.37 first, the green line or the red line?
Green.
Green.
This is tau 2, this is tau 1. Na? Time constant ka definition is the time in which the current becomes 63% or charge increases by 63%. You can clearly see here the time constant of the red one. Time constant 1 is greater than 2. So tau 1 is greater than tau 2. What is time constant? R1 C1 is greater than R2 C2. But you said R1 is equal to R2, so C1 should be greater than C2, no? Please check. If the resistance is constant, so whoever has more capacitance will have more time constant, meaning it will take more time to decay. Logically, it's a if you have a bigger capacitor, it will take more time to decay. Means your slope will be gradually more flattish. Whoever has small time constant means you'll decay very fast. Look at the meaning of time constant, the time to decay. So if your time constant is small, means you will mess up faster. The capacitor will discharge much faster. All clear with this? This is about RC circuits. RC circuits is pretty important in the current electricity. There's a pretty good weightage. And exact similar things will again repeat in a chapter called EMI. There we do LR circuits. Do have a look at this. Clear? Next one.
One second.
Yeah.
सर जो I का जो इक्वेशन आया था V by R
Hmm.
उसको dt के रिस्पेक्ट में डिफरेंशिएट करके स्लोप कंपेयर नहीं कर सकते?
जीरो हो जाएगा गॉड. तो पहले फाइंड करंट आई एज अ फंक्शन ऑफ टाइम टी एंड देन करना पड़ेगा. ये कांस्टेंट को कैसे डिफरेंशिएट करोगे शौर्य?
नो उसमें e raised to minus t by RC भी तो है.
तो करो ना, वो कहाँ पे लेके आना वो सब इक्वेशन. बिना वो सब तो आ रहे हैं ना इजीली. इतना फाइट क्यों मारना है?
Okay.
You can do that. If you remember the decay function, you can do that. Clear, everyone? Next thing, non-ideal batteries. So till now, all the batteries we studied were ideal, meaning they had no resistance. But in reality, if you see a battery, right, they always have some own resistance due to the materials used. There is always an internal resistance. You can't avoid this. So whenever you take a battery, this is how we define this. So we say battery ka symbol is actually this. So this dotted line is completely taken as battery. So EMF is E. The internal resistance is R. So E is called EMF. R is called internal resistance, which cannot be eliminated. So this is point B and this is point A. So if you take current I flowing in the circuit like this, the potential difference VA minus VB is equal to E minus IR. So this term is your potential difference. Now be careful here. Potential difference is different from EMF. We'll talk about more that in the next page. Potential difference is different from EMF. Have a look at this.
सर VB minus VA नहीं होगा, वो नेगेटिव हो जाएगा ना?
Calculate करके देख ना VA minus VB. You're going from left to right ना? तो VA minus IR plus E is equal to VB.
Okay.
ना VA minus R plus C is VB.
Okay.
Yeah. Please check everyone. Did you ever notice this thing in your house now? I don't know whether it happens now or not. When your refrigerator sometimes will suddenly make a sound, boom, करके it makes a sound, and suddenly lights dim. कभी हुआ? Observe
Tripping
किया
of
कभी?
wire.
Tripping नहीं है, वो अलग है. I have noted. I think maybe right now nowadays the fridges are not like this. Refrigerators previously, right? Suddenly, na it works. You know, it something happens, the compressor or something will start working. The kitchen ka lights will dim for a moment and come back to normal. Did you ever observe that?
सर AC और बेडरूम में होता है सर कभी.
AC में भी होता है actually. When you switch on the AC or something, na, if you have a tube lights, the bulb will dim for a moment and come back to normal. Or same thing, you know, when you see it start the car ka headlights will dim and become normal. That you must have observed. Whenever you're starting the car ka headlights will dim and then become normal again. The reason why all this happened, right, is because of this EMF and potential difference. See what is happening, I'll tell you. Example, let's say you have a battery with internal resistance. So this whole setup is a battery here. let's say EMF is, let's say this thing is some 13 ohms. Let's say the internal resistance is 2 ohms. Your ever ready ka battery aata hai na, uska voltage is 1.5 volts, isn't it? So if you take the current I here, we get I is equal to 1.5 by 15 ohms, which is 0.1 ampere. So if you look at these 2 points here, potential difference A and B, VA minus VB will be E minus IR. This thing turns out to be 1.5 minus 0.1 into 2. We get actually 1.3 volt. What is the meaning of this? Even though the battery says 1.5 volt, in reality, we get only 1.3. You're getting it? Battery mein to likha hoga 1.5 volt. So the external resistance, so this is your R external. This can be a bulb or anything. The R external receives 1.3 volt, even though the battery says 1.5 volt. Are you getting this? Now, what happens in this car and refrigerator or AC and everything? Can you tell me one thing? In the house, right? All your circuits are connected in series or parallel? In your house.
Parallel.
Think na, if it is in series, kya hoga pata hai?
एक
If it is
fuse
in
होगा तो सारे
series-
fuse.
Yeah, let's say there's a bulb, you have your TV there, you have a refrigerator or something. For some chance, the bulb gets fused. Disconnect ho gaya. So what will happen? Everything will stop working, right? All your equipment in the houses are in parallel. So what you guys don't notice is, you know how much wire they use in your electrical wiring in the house? Matlab socho na, if there's a plug point here with 3 plugs, one goes to the wire, matlab the wire will go from here to the fan and comes back here. This wire will go from here to this bulb and comes back here. This wire will go to the TV and comes back here. Literally the wire goes, comes back, wire goes, comes back. You have multiple wires like this, all are in parallel. So maybe in your house, right, if you actually pull out all the wire, aram se you'll find that wire will exceed a kilometer, 1.5 kilometer length. You have so much wiring in the house, we just don't notice it. You're getting it? So there's a story like this, huh? US may, you know, when they build the skyscrapers, 100 floors, 120 floors. So when they're giving for a contract, no, a certain company has quoted the price. So they have this contract, right? Every company will come and give a quotation. I will build the whole building in this cost. So out of all the companies, there is one famous company which quoted, and they quoted the minimum, least amount, and they won the bid. So company people are very happy. And after a month, they noticed something very dangerous. They noticed that, you know, that whoever made the report, they forgot to add the cost of the electrical wiring for the building. So pura expenses mein, right? The amount of money required to build a building, in that it will be like foundation, cement, workers, employees, lift, sab dal ke electrical wiring ka bhi cost hota hai na? Someone forgot to add the cost of the wiring. And that cost went into at least, you know, around 20 or 30 million dollars. The company went bankrupt. They lost the deal. The company shut it down. Then the project went to some other company to do. Electrical wires are expensive. Copper, na? Copper is expensive. Copper is expensive. Wires is still expensive hota hai. You can't use any dabba wires.
Sir, but we learned that copper is cheap in 10.
Copper is?
Cheap compared to other wires.
Ah, na, it is cheap.
Alternative is silver, no?
Silver, Rishi, meaning we are not that rich. Right? Silver.
No, exactly. Cheaper to silver. Copper is cheaper to silver. Because alternative is
cheaper
silver.
to silver. Copper is expensive than aluminium. So copper is expensive है ना. Maybe I think school में cheap था, but अभी बहुत expensive हो गया copper. Problem क्या है ना? We are using so much smartphones, your cables, that thing, this thing, right? It became quite expensive. You know these graphic cards, computer gaming के लिए we use. During my time, they used to be very, you know, I won't say cheap, but they're okay था. इतना expensive नहीं था. But you know, around 2015 to 2020, the computer graphic cards become very expensive. You know why? People started using graphic cards for Bitcoin mining. Bitcoin and Ethereum mining, right? Heard about Bitcoin, right? Cryptocurrency. So there is something called a mining. You have to, use a software, a kind of high processing power to decode the algorithms. So these people became so smart. ये लोग क्या करना क्या पता है? They started using this gaming का CPUs, gaming का graphic cards in order to use for Bitcoin का mining. So instead of constructing, there is something called a Bitcoin mining rig. You can construct that, which goes a little expensive. Someone came up with a brilliant idea. Why don't you use gaming cards, graphic cards? And they started buying from the market graphic cards in bulk. The price of the graphic cards for gamers, right? It went up almost 5 times. So when Bitcoin mining started, right, it was a dark age for gamers. The entire, I still remember, right, when I took a quotation for a computer, right, before this Bitcoin mining, it was costing like 70,000. The same graphic configuration, right, thoda little higher processing power, it was costing more than 2.5 lakhs. Just because of the bloody graphic card. I didn't buy though, Alak story. I said like, where the hell will I play so many complicated games? So yeah, it happens like that. Okay. So how does this work? Why does your bulbs become dim in that thing? Look at the reason. So everything is connected in parallel. So let's say this is your power supply, E and R. So this is your bulb in the house. Let's say, headlight for the vehicle. And let's say this is the switch. Now see what happens here. Initially in the circuit, now current is flowing I1. This current is flowing I1. When you suddenly close the switch, now what happens in the circuit? This current will be I1, this current will be I2, current in the circuit will increase. I1 plus I2. And what is the potential difference? VA minus VB will become E minus I1 plus I2 into R. Na? So whenever you start the vehicle, you actually use the current to produce an ignition spark. That spark will combust the fuel and you'll start. Ever Activa ko start karke dekha? You press that button, no? There's an electric switch. Karke it starts. That's actually an electric switch. You're producing a spark inside. That is produced by actually, opening and closing the circuit. So because of this, what happens when current increases, the potential difference drops. The bulb becomes dim. But in a vehicle, what happens? That you use the current only for a second. The bulb will go back to normal again. When current increases, potential difference drops and the bulb becomes dim for a moment. Clear? So next time when, you can see this thing, you get into the car, you switch on the headlights, you start the car, you will see the headlights will dim and then come back to normal. Because when you switch on the car, the headlights will, the engine will take more current, the headlights will dim. Have a look at this. So this is the problem with the non-ideal batteries. What is written on the top and what you get are two different things. So every battery that you see, 1.5, in reality, you'll never get 1.5. You're getting less than that. And more current you take from the battery, the less voltage you get. Check these examples once.
So that there will be I1 plus I2 into small r, no?
Smaller.
Sir, but if we get low potential, what will happen?
Low potential तो circuit काम ही नहीं करेगा. कभी try करके देखा? वो battery car होता है ना? You put 4 batteries.
Yes.
It will work, but evening तक batteries खत्म हो गया. You take the battery and put it in a watch. Watch अच्छे से काम करेगा.
Yes, yes.
Because watch के लिए इतना voltage नहीं चाहिए.
Okay.
Watch का काम बंद हो जाएगा. Take the battery and put it in TV का remote. TV remote will work properly.
Yes.
Because TV remote does not need as much voltage as a watch. उसके बाद काम नहीं कर रहे तो बैटरी का है, उसको कुछ नहीं कर सकते हो. अभी like TV remote and AC remote is the last option you have in the house. They take the minimum voltage. Clear? There. So let's see how does this work then. So the resistor, internal resistor, battery. So this is R, this is small r, and this is EMF. This is A and this is B. And this is current I. So if you look at the potential difference here, VA minus VB is equal to E minus IR. So be careful with this thing. EMF of a battery, potential difference of a battery are not same. So if you try to plot this graph, if you plot a graph between VA minus VB versus current, this is what you will see. It's a linear function. Can you see this? It looks like a straight line equation. This looks like y is equal to minus IR minus R into I plus E. This looks like y is equal to mx plus c. It's a straight line equation with a negative slope. So at this point here, R is 0, meaning potential difference is 0. So I is E by R. At this point here, R is infinity, means there is no circuit only. Potential difference become EMF. If R becomes infinity, that is open circuit. मतलब resistor connect किया ही नहीं, then E becomes VA minus VB. If R becomes 0, that is it becomes wire. Then VA minus VB is 0. There is no potential difference. Then E minus IR is 0. I is equal to E by R. So if you have a battery and if a current I is coming out, this is called discharging circuit, meaning battery is getting discharged. So we get VA minus VB is equal to E minus IR. This is what happens when you are charging your mobile phone. No, not your mobile phone. Your mobile phone is getting discharged. When you're using a battery in a watch, the battery is being discharged.
Some
But
means
when you-
ideal battery तो कभी discharge नहीं.
Ideal battery, मतलब then ideal battery smaller 0 है ना, EMF और potential difference same आएगा.
Okay.
Suppose if you send the current into the battery, this is the charging the battery. This is what you do when you charge your mobile. In this case, the potential difference VA minus VB will become E plus pi IR. This is the charging the battery. Have a look at this. You know, your laptops and all these things will work at 12 volt DC. Your laptops work at 12 volt DC. तो adapter होता है ना, next time observe करके देखो, adapter में it will be written that 12 volt DC करके. So what these people do, there's actually that adapter होता है ना, that big dabba kind of thing with the wire. That's actually AC DC converter. It converts, AC current into DC and then it supplies to your laptop. Your laptops don't use AC current. They use DC. You know what else uses DC? You see this every day in Mumbai.
Rains.
Train. Local trains.
Trains.
Trains. Your local trains are actually DC engine, pata hai? Your local trains run on DC, not AC. But power supply, what you supply is AC. AC motor ka problem kya hai na? The supply is not constant. The engine will have a rattling effect. DC motors have more torque. And you can pull the more force with that. So where is a DC AC converter? Next time observe this, local train ka compartment if you see na, you have this pylon on the top. Uske niche dekho, this will be completely sealed. You can't get into that. That part is completely sealed. You get the electricity from here. This is a AC current which goes into this. You convert from here AC to DC and you run the motors here. That is actually an engine room. A local train has 3 engines. ये passenger train देखते हैं ना, which goes from city to city, intercity. That has actually one engine in the front, right? It is pulling all the compartments. उसका problem क्या है ना, you can't stop the train fast, you can't start the train fast. But local trains, you have to stop every 4-5 kilometers, isn't it? So you have multiple engines. You have 3 engines in that thing. Observe करके देखो, local train will have 3 compartments like this.
But did you see that the laptop charges are DC adapters?
They're DC adapters.
So I
They
just
convert
checked.
they convert AC to DC, na?
So I just checked the adapter on my laptop charger. It's written AC adapter.
AC adapter matlab it takes AC and makes it into DC for laptop. Your laptops work on DC voltage, right? They never work on AC. All electronic chip works on DC. AC circuit, so they'll get fried. It's an AC adapter, matlab it takes AC current and makes it into DC. Have a look at this. Shaurya has a ghost laptop, it seems. It works without any power. क्या ghost laptop क्या होता है रे?
Sir, it works on AC.
चलो शौर्य का बस ऐसा कुछ है. तो I'm talking about normal human being का laptop. So on Earth creatures के लिए बारे में बात कर रहा हूँ. From your planet we don't know anyone. So put this down. Ghost laptop it seems. चलो अच्छा है. At least you said some power is there. Clear? Now, combination of batteries. So what happens if you connect a lot of non-ideal batteries? First thing, series.
Sir, so if there is an appliance in the circuit, so the current which is released from the battery, that net current will also come back in the battery.
Yeah, obviously. Battery में जो बोल रहा हूँ ना, देखो ना शौर्य कैसे है ना, battery will not create any new charge.
Sir, so how it is discharging? मतलब ये पूछ रहा था मैं.
Discharging मतलब battery current से बाहर आ रहा है, तो it's getting discharged.
But उसमें उतना जा भी तो रहा है वापस, मतलब current.
अरे it is like a conveyor belt, रे God. It's a motor which is pumping the electrons, right? It is pushing them and
Okay.
they're coming back. They're pushing them, they're coming back. Every time they come back, they come slower, na? You have to keep pushing them non-stop.
Okay.
You know what you're saying? Escalator कभी देखा?
Yes, sir.
Escalator ऊपर जाएगा, वापस आ जाएगा.
हाँ.
तो उसको कुछ मोटर डालने की जरूरत नहीं है क्या? Will you run it without any motor inside?
No. Requires.
It is like that. Same thing. In place of a escalator conveyor belt, you have electrons moving around. So Rn, En, so you can replace this with one single battery like this. R equivalent and E. So you can just add up all of them. R equivalent will be sigma Ri. And E will be sigma Ei. So if you have all the batteries are identical, if n batteries are identical, then this whole setup will become NR and NE. Check. You can just add up the batteries like a single battery. Cells in series. Clear? Next one. Let's see a question, how they'll frame a question. Huh? This was asked something in the exam like this. There are 10 identical batteries like this, R and E. A student accidentally connects 2 batteries in reverse polarity. मतलब रिवर्स में कर लिया था, पॉजिटिव नेगेटिव टर्मिनल को रिवर्स में कर लिया, accidentally connects two batteries in reverse polarity. What is reverse polarity? Look at here, huh? All positives are in the same direction. So this guy accidentally connected two batteries in reverse. Find R equivalent and EMF equivalent. Find equivalent battery. Let's get this. Six are near Yatisha. Resistance will never cancel. Huh? Nahi Kavish, you're goofing up. See what's happening. I'll give you a general one. Huh? Let's say if there are n batteries. And if m batteries are connected in reverse. What will happen? Tell me one thing. See, think of like this, okay? Let's say in your team, there are 10 people. In my team, there are 10 people. If 2 people from my team leave me and go to you, what will be the difference in our strength? I will become 8, you will become 12. Difference 4 hoga na? It is not 2. I lost to 2 people. On top of it, those 2 became my enemies also, isn't it? So, when you connect these batteries here, the EMF will be, there are n batteries, n minus 2m into E na. You lost m batteries and m batteries will be reversed to you. So m batteries will cancel again. Are you getting it? So you actually lose double the batteries. And what about the resistance R equivalent? NR. Resistance will always add up. Easy? Please check. Resistance will be same, but the EMF will become 60. Clear? Next thing. Cells in parallel. So on. Let's say if you have so many batteries here, E1, R1, E2, R2, En, Rn, and this is R. So where R is your external resistance. So the derivation is really not that important. What we can do, you can calculate इतना बड़ा deal नहीं है. Let's say this current is I1, this current is I2, this current is In. We get the total current I is equal to I1 plus I2 plus so on till IN. And we can write Kirchhoff loop law through each equation. We get E1 minus I1 R1 minus capital IR is 0. So I1 will be E1 minus IR by R1. Similarly, E2 minus I2 R2 minus IR is 0. E2 minus IR by R2. So on, if you do this, En minus In Rn minus IR is 0. You're getting, I'm writing Kirchhoff's loop law through this guy, like this guy, like this guy. In will be En minus IR by Rn. If you add all of them, you get I1 plus I2 plus In, that becomes I only. And you end up here sigma EI by Ri minus I into R sigma 1 by Ri. You can take out I common here. Sigma EI by Ri by 1 plus R into sigma by 1 by Ri. This is the current in the external resistor when you have N batteries. Technically speaking, ये इतना useful नहीं है. Let me show you something more useful format in the next page. But this is how you derive for N batteries. Have a look at this. Clear? So a better way of using this, if you have only 2 batteries, right, it becomes more useful for us. See. Case 1, let's say if you have 2 batteries like this. E1, R1, E2, R2. And both the positive terminals are connected to the same terminal. This can be replaced by one single battery and one single resistor, where this E is given by E1 R2 plus E2 R1 by R1 plus R2. And this R equivalent can be replaced by R1 R2 by R1 plus R2. You can replace the circuit of these two, right, with one battery and one resistor like this. Makes your life much easy to solve. Suppose if you give it in reverse. Let's say this is E1, this is R1, this is E2, this is R2. So if you put the battery in the direction of E2, so this will be E2 R1 minus E1 R2. Suppose if you keep it on the right hand side, reverse ho jayega. You're getting it? You're trying to put the positive direction in the direction of E2 by R1 plus R2. R equivalent will be R1 R2 by R1 plus R2. Remember, this is quite a useful thing, saves a lot of time.
Sir, ये वो capacitors में polarity reverse करने वाले जैसे
Yeah, थोड़ा है something ऐसा ही है. उसमें but वो voltage across the capacitors ना ये अलग है. Put it up. Have a look at this. Let's see a problem on this.
But could I go to the last page one? Yep. Answer.
Have a look at this.
सर अगर E2 E1 के डायरेक्शन में होगा तब सिर्फ एक माइनस आएगा या
हाँ, E1 R2 minus E2 R1 हो जाएगा. हमने assume कर रहे E2 का पॉजिटिव है, तो स्टार्ट विद E2. अगर आपने E1 positive assume किया, then battery we will write like this. Then I'll write E1 R2 minus E2 R1.
Oh.
All clear with this? So let me show you how they'll try my question. $10V, 2 ohms, 3 ohms, 5V. This you connected to a 2 ohm resistor. So normally we have to use Kirchhoff's law to solve this. Assume current I from this branch, put I1, I minus I1 करके solve करना पड़ेगा. But this will give you the answer pretty fast. Find the current in the 2 ohm resistor. $10V, 2 ohm, 5V, 3 ohm. This is a 2 microfarad capacitor. Find charge on the capacitor. I can use this as long as I get this thing. I can use it for a capacitor or anything. Let's get this. I hope everyone started solving capacitors. Start working on this. Finish off by Saturday. Wind up capacitors by Saturday. Have to start doing current from Saturday. We will wrap up the chapter mostly on Saturday, Sunday. Next week we'll start off with waves. I think maximum you'll get 1 week to 10 days for every chapter to solve. More than that, I don't think you'll get a time. 1 week, 10 days, I think you should be able to manage. Okay.
Sir, 3.
3. Okay. Charge bhi nikal.
Sir, can you show previous papers?
Okay.
Yes, sir.
See now, everyone. This was easy. So here, what is E battery? So you can replace this with one battery here with a 2 ohms. So this R equivalent will be R1, R2, that is 3 into 2 by 3 plus 2, 6 by 5. And this EMF will be E1, R2, that is 10 into 3 plus 5 into 2 by R1 plus R2. That would be 30 plus 10, 40 by 5, that is 8 volts. What is the current in the circuit? I will be E by R plus small r plus 2. That will be 8 by 6 by 5 plus 2. Easy. Same thing here also. Capacitor, battery, and this would be a capacitor here. Steady state, na? So charge Q is equal to CV. So this battery voltage E will be 10 into 3 minus, it will be minus now, 2 into 5 by R1 plus R2. That is 30 minus 10, 20 by 5, 4 volt. So this charge will be C 2 microfarad into 4, 8 microcoulombs. 6. So itna hi karna. Just replace the whole thing with one battery and finish it off. Is this clear, everyone? So you just replace the whole thing with one big battery and one resistor, and you can solve. Saves you a lot of time, or else you have to use actually Kirchhoff's law. That will be quite messy and lengthy. Assume the current is I, let this current be small I, this will be I minus I, apply loop, and solve. All clear with this? Any doubts on this, please ask me. Labdi, clear? Dipanshu, Trisha, Rishi, Kavish, Kavya, clear? Great. That's the last one for the day. So next class when we meet, right, we are going to mixed grouping. What happens if you have batteries both in series and parallel?